Ever heard of NOx and wondered what it is? Well, you're in the right place. Bill Nye here, ready to dive into the world of chemistry and environmental science. We're going to unravel the mystery behind these gases and understand why they matter to our planet and our health. Today we're talking about NOx. These gases are released from various sources, many of which are tied to our modern lifestyles. From the factories that produce our goods to the vehicles we use to get around, NOx is a byproduct of many processes. NOx, that's NOx, is a collective term for a group of gases called nitrogen oxides. It's not just one single gas, but rather a family of compounds that share a common characteristic. They all contain nitrogen and oxygen. NOx is a family name for gases like nitric oxide, NO, a colorless gas that plays a role in various biological processes, but also contributes to air pollution. And nitrogen dioxide, NO2, a reddish-brown gas with a pungent odor that's a significant component of urban smog. It's the one you can sometimes see hanging in the air on a bad air quality day. The X in NOx just means there could be one, two, or even more oxygen atoms attached to the nitrogen atom. It's a variable, representing the different possible combinations of nitrogen and oxygen. These gases are a type of air pollution, contributing to a range of environmental and health problems. They're not something we want hanging around in our atmosphere in large quantities. They're created when things get really hot, like inside car engines, where fuel is burned at high temperatures to power our vehicles. The combustion process is a major source of NOx emissions, or power plants, which burn fossil fuels to generate electricity. These facilities release significant amounts of NOx into the atmosphere. Normally, nitrogen and oxygen in the air are quite content to ignore each other, existing as separate molecules. They don't readily combine under normal conditions, but with enough heat, they react and form NOx. The high temperatures provide the energy needed to break the strong bonds holding the nitrogen and oxygen molecules together, allowing them to recombine into nitrogen oxides. Why care? What's the big deal about NOx anyway? NOx is a major player in smog, that hazy brownish air pollution that hangs over many cities. It reduces visibility and can make it difficult to breathe. Acid rain, which damages forests, lakes, and buildings. NOx reacts with water in the atmosphere to form nitric acid, a key component of acid rain, and tiny dust particles that can get deep into our lungs, causing respiratory problems and other health issues. These particles, known as particulate matter, can be formed when NOx reacts with other pollutants in the air. Even though you can't see it, NOx is silently impacting our environment and our well-being. It's a hidden threat that we need to address. NOx affects our health and our planet, contributing to respiratory illnesses, damaging ecosystems, and even impacting climate change. Understanding NOx, its sources, and its impacts is the first step to solving these problems and creating a cleaner, healthier future. It's a story of how simple elements, nitrogen and oxygen, the very air we breathe, changed by the energy we use in our cars, factories, and power plants, can cause big issues on a global scale. But here's the good news. This isn't a problem we're powerless to solve. Because we know how NOx is made, we understand the chemical reactions and the conditions that lead to its formation. We can use science and technology to make less of it, developing cleaner engines, more efficient power plants, and alternative energy sources. Stick with me as we explore this powerful molecule and delve into the chemistry behind NOx, and how we can work together using our knowledge and innovation for cleaner air and a healthier planet for everyone. Ready to learn more and make a difference? Let's go. Scene transition. So, how is NOx actually made? It's a question that has driven a lot of scientific research, and the answer lies in understanding the fundamental chemistry involved. We need to delve into the processes that occur at a molecular level to truly grasp the origins of this pollutant. The secret ingredient, the catalyst that makes it all happen, is heat, intense heat. Inside the combustion chambers of car engines and the massive boilers of power plants, extreme heat, reaching temperatures of thousands of degrees, causes the nitrogen and oxygen molecules present in the air to break apart and then, crucially, to recombine and form various oxides of nitrogen, collectively known as NOx. This is a chemical reaction driven by thermal energy. It's not just cars with their internal combustion engines constantly churning away. Power plants, whether they're burning coal, a solid fossil fuel, or natural gas, a gaseous one, and factories engaged in energy-intensive processes like making cement, a key building material, or steel, the backbone of modern infrastructure, all contribute to the creation and release of NOx into the atmosphere. Even some seemingly innocuous home appliances, the ones we use every day like gas stoves used for cooking, produce small but not insignificant amounts of NOx during their operation. Basically, whenever we burn something, anything, at high temperatures in the presence of air, which is mostly nitrogen and oxygen, we're inadvertently creating NOx as a byproduct. NOx isn't made on purpose, nobody sets out to create it. It's an unavoidable consequence, a byproduct of our insatiable need for energy to power our modern lives. The way we've powered our world, relying heavily on combustion for the last century, since the dawn of the Industrial Revolution, has this built-in, often overlooked environmental consequence. But by meticulously studying where and how it's formed, the conditions that lead to its creation, scientists and engineers can design cleaner, more efficient, and more sustainable ways to power our world, minimizing the formation of NOx and other harmful pollutants. That's the power of science. The ability to understand the world around us and use that knowledge to create a better future. Not all NOx is created equal. While all nitrogen oxides share the same basic chemical structure, their origins and the processes that lead to their formation can vary significantly. Understanding these differences is crucial for developing effective strategies to minimize their production and release into the atmosphere. NOx emissions aren't a monolithic problem. They arise from a multitude of sources, each with its own unique characteristics. From the towering smokestacks of power plants to the internal combustion engines of our vehicles, and even certain industrial processes, the conditions under which NOx forms can differ dramatically. To better understand and manage these diverse sources, scientists group NOx into three primary types, based on their formation mechanisms. This categorization helps in tailoring specific control measures to address the root causes of NOx emissions. These three types are thermal, prompt, and fuel NOx. Each of these categories represents a distinct pathway through which nitrogen oxides are generated during combustion processes. Thermal NOx forms at extremely high temperatures, typically above 1300 degrees Celsius, like in engines and furnaces, where the intense heat provides the energy needed to break the strong bonds of nitrogen molecules in the air. This allows nitrogen and oxygen in the air to react, forming NOx compounds. The higher the temperature, the more thermal NOx is produced. Prompt NOx, on the other hand, forms right at the start of combustion, during the very early stages of the flame. This occurs in the initial flame zone where highly reactive hydrocarbon radicals interact with atmospheric nitrogen. These interactions proceed through fast, complex reactions, leading to the formation of intermediate nitrogen-containing species that eventually convert to NOx. Fuel NOx, as the name suggests, comes from nitrogen that's already inside the fuel itself, bound within the molecular structure of the fuel. This is particularly relevant for fuels like coal or heavy oils, which can contain significant amounts of organically bound nitrogen. During combustion, this fuel-bound nitrogen is released during burning, and subsequently oxidized to form NOx. Cleaner fuels like natural gas, which are composed primarily of methane, have less nitrogen in their chemical structure, so they make less fuel NOx compared to heavier, nitrogen-rich fuels. In real engines and furnaces, you rarely find just one type of NOx formation occurring in isolation. Instead, you get a mix of all three types contributing to the overall NOx emissions. Therefore, engineers have to understand these recipes, the relative contributions of thermal, prompt, and fuel NOx, to tweak conditions, optimize combustion processes, and prevent as much NOx formation as possible. This often involves strategies like lowering combustion temperatures, controlling air-fuel mixtures, and using cleaner fuels. It's a fascinating challenge in applied chemistry, requiring a deep understanding of chemical kinetics, thermodynamics, and fluid dynamics to minimize the environmental impact of combustion processes. Now let's see why NOx is such a troublemaker. Smog. In cities, NOx from cars and smokestacks rises into the air and gets hit by sunlight. Sunlight breaks apart NO2, releasing a reactive oxygen atom. That atom joins with O2 to make O3, ozone. High up, ozone protects us. Down here it's a pollutant and the main ingredient in smog. On hot, sunny days, NOx and other pollutants cook in the sun, making more ground-level ozone. That's why smog is worse in summer. The brown color in smog comes from nitrogen dioxide. Smog isn't just ugly, it's harmful to breathe, irritating our lungs and making asthma worse. Tackling NOx means fighting smog and protecting our health. NOx doesn't stop at smog, it also causes acid rain. NOx travels in the air, reacts with water, and forms nitric acid in clouds. When it rains, this acid falls to Earth, slowly damaging forests, lakes, and soil. NOx also helps create PM 2.5, tiny particles smaller than a human hair. These particles form when NOx reacts with other pollutants in the air. PM 2.5 is dangerous because it can get deep into our lungs and even enter our bloodstream, causing serious health problems. So NOx is a building block for both acid rain and invisible harmful particles. NOx pollution ripples through entire ecosystems. Acid rain leaches nutrients from soil and releases toxins, weakening trees and harming forests. Lakes and streams become more acidic, threatening fish and aquatic life. NOx also causes nitrogen deposition. Extra nitrogen falls to the ground, over-fertilizing ecosystems. This can trigger algae blooms in water, creating dead zones where nothing can live. On land, it favors fast-growing weeds, crowding out native plants and reducing biodiversity. The NOx from our engines and smokestacks is directly connected to the health of our forests, lakes, and wildlife. Let's talk about our health. Breathing in NOx, especially nitrogen dioxide, irritates our lungs and airways. It's especially dangerous for people with asthma or chronic lung disease, and for children. NOx also helps create PM 2.5, which can get deep into our lungs and even our bloodstream. Long-term exposure is linked to asthma, bronchitis, heart attacks, and strokes. Air pollution travels, so it affects entire communities, not just those near highways or factories. Reducing NOx is a public health imperative. The good news, we have solutions. Cars use catalytic converters to turn NOx into harmless nitrogen gas. Power plants and factories use selective catalytic reduction injecting ammonia to convert NOx into nitrogen and water. These technologies can remove up to 90% of NOx from emissions. Laws like the Clean Air Act set limits on NOx, pushing industries to innovate. Thanks to these rules and technologies, air in many cities is cleaner today. We can help too. Walk, bike, use public transit, and keep our cars maintained. Conserving electricity at home also reduces NOx, since power plants burn less fuel. Every little bit helps make a big difference. We've learned that NOx comes from burning fuel and causes smog, acid rain, and harmful particles. But we can do something about it. Understanding how NOx forms lets us engineer cleaner engines, power plants, and cities. Reducing NOx isn't just about meeting standards. It's about the world we want to live in. It means clear skies, healthy forests and lakes, and better health for everyone. Every action, big or small, helps. By supporting clean technologies and making thoughtful choices, we can reduce NOx pollution. Cleaner air means a better quality of life for all. Let's be NOx aware and keep working for a healthier planet. Thanks for exploring with me.